This video covers Appendix C2, Systems of Linear Equations in 3 Variables. Objective 1, find the equation of a quadratic function containing 3 points. When we find equations of quadratic functions, we need to have 3 points to find a unique quadratic function. Quadratic functions take on the form of f of x equals ax squared plus bx plus c. When we find the quadratic function that contains the 3 points, we're going to plug in the x equal to -1 and the f of -1 equal to -4, and it's going to give us an equation in the 3 unknowns, a, b, and c. We'll do that for x equals 2 and f of 2 equals -19, and that'll give us a second equation. And doing that same thing for -3 for x and f of -3 equals -14, we'll have a third equation in 3 unknowns, and we'll have to solve it by elimination. So remember, we solve systems of equations by elimination by getting one of the variables to have opposites. The coefficients need to be opposites. So this -2 there, I could multiply it by 2 to end up with the opposite of 4. And that would give me 6a minus 4b equals 10. To make that a -4, we had to multiply everything by 2. When we add those two equations together, we get 11a equals 33, which gives us a equals 3. Plugging that back into the first equation, 3 times a is 9, minus 2b is 5. When you subtract 9 from both sides, we have -2b is -4, or b is equal to 2. So we get a equals 3 and b equals 2. That's how you solve a 2-by-2 system. 2 equations, 2 unknowns. We're going to be setting up 3 equations in 3 unknowns, and we'll solve those ones by elimination method as well. We start off with our quadratic function in the most general form with our unknowns a, which is in front of the x squared, the b, which is in front of the x, and the c. And the first point, -1, -4, tells us that f of -1 is -4. So when we plug in -1 for x, we know that result is -4. Well, -1 squared is 1, so that just gives you a. -1 times b is minus b, and plus c equals -4. Let's call this equation 1 for reference later. The second point says f of 2 is -19. So if we plug in 2 for x, we'll get 4a plus 2b plus c is -19. We'll reference this later as equation 2. And the last point says that f of -3 is -14. So plugging -3 in for x, that output is -14. So -3 squared is 9. -3 times b is -3b. Plus c is -14. And we'll refer to this one as equation 3. Now, the pieces of this to pay attention to are the fact that they're all plus c's there. Those are the variables that you want to set out to eliminate. And so I would just have to multiply one equation by -1 and then add that to the other equation, and it'll cancel the c's. So I'm going to multiply equation 1 by a -1, and then I'm going to add that to equation 2. Multiplying equation 1 by -1 gives me -a plus b minus c equals 4. Changed all the signs in equation 1. And I'm going to add that to equation 2. 4a plus 2b plus c is negative 19. When I add these two equations together, the c's are going to cancel, but I'm going to get negative a plus 4a is 3a. B plus 2b is 3b. And 4 plus negative 19 is negative 15. That's my new equation that I'm going to use here in a little bit. I used equation 1 and 2 to eliminate c. Now I can use equations 1 and 3 to eliminate c. They still all have plus c's on them, so I'll do the same thing as before and do negative 1 times equation 1 and add that to equation 3 this time. The opposite of equation 1 is negative a plus b minus c equals 4. Equation 3 remained the same. And when I add those two equations together, I get 8a. B minus 3b is negative 2b. And negative c plus c is 0. 4 minus 14 is negative 10. That's my new equation. These two equations together now form my new 2x2 system that we're going to use to solve for a and b, just like the practice problem. When you see that your two equations have a common factor like the first one does, everything divisible by 3, it's going to be much easier if we divide everything by 3. The second equation is all divisible by 2, or each term is divisible by 2, so I get 4a minus b equals negative 5. And just by doing that, we see the b and the negative b. We can add those two equations together and get 5a equals negative 10. Dividing both sides by 5 gives us a equals negative 2. This 2x2 system is what we use to find b. We can use any one of these 4 equations to find b. So I like to use one of the first ones there, the 3a plus 3b is negative 15. That's negative 6 plus 3b is negative 15. Adding 6 to both sides gives me 3b equals negative 9, or b is negative 3. All right, so we got a equals negative 2. We've got b equals negative 3. Now, to find c, we go back to one of our very first equations that said a minus b plus c is negative 4. We've got a as negative 2. We've got b as negative 3. Negative 2 minus a negative 3 is negative 2 plus 3, which is 1. And that tells us that c is negative 5. Okay, so let's write these down. We've got a equals negative 2, b equals negative 3, and c equals negative 5. So we place this back into our quadratic function. F of x is a x squared plus b x plus c. Now, I think that's the answer. I'm not 100% certain until I plug these numbers back in. If I plug -1 in, -2 times -1 squared, that's 1 times -2, which is -2. -3 times -1 is +3 minus 5. That's -7 plus 3 is -4, and that is checked. If I plug in 2, I should get -19. -2 times 2 squared minus 3 times 2 minus 5. That's -8 minus 6. -14 minus 5 is -19. And the last one, if I plug in -3, that's -2 times -3 squared minus 3 times -3 minus 5. -18 plus 9 is -9 minus 5 is -14. And now I can be confident that that's my answer. The unique quadratic function that contains these 3 points is f of x equals -2x squared minus 3x minus 5. Here's a practice problem for you to try. I encourage you to press pause on your video and work this out and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. We start with our general quadratic function, f of x equals a x squared plus bx plus c. F of 1 equals 1, so we have f of 1 equals a times 1 squared plus b times 1 plus c, and that output is 1. So that equation just tells us that a plus b plus c is 1. That'll be our first equation. The second one says f of 2 is 12, so we have a times 2 squared plus b times 2 plus c equals 12, or 4a plus 2b plus c equals 12. And that's equation 2. Equation 3, f of -3 is a times -3 squared plus b times -3 plus c equals 17. -3 squared is 9 minus 3b plus c equals 17. And that's equation 3. These problems will always work out to where you have these plus c's in them. So we're going to take -1 and multiply it by equation 1 and add that to equation 2. So that's -a minus b minus c equals -1. And equation 2 is 4a plus 2b plus c equals 12. Adding those two equations together, we have 4a minus a is 3a. 2b minus b is b. C's cancel, and 12 minus 1 is 11. That equation we'll keep track of and use here in just a little bit. This time we'll use equations 1 and 3. We'll take the opposite of equation 1 and add that to equation 3. -a minus b minus c is -1, and 3 will be unchanged, 9a minus 3b plus c equals 17. -a plus 9a is 8a. -b minus 3b is -4b. And -1 plus 17 is 16. That's my second equation. I'll put these two together. 3a plus b equals 11, and 8a minus 4b equals 16. That second equation has terms that are all divisible by 4. So let's divide them all by 4, and then we'll get 2a minus b equals 4. Now that's solved pretty easily by adding the two equations together. We get 5a equals 15, which gives us a equals 3. Plugging that back into the first equation, 3a plus b equals 11 tells us that b equals 2. So we've got a equals 3, b equals 2. And now to find c, we'll use that first equation that says that a plus b plus c is 1. A is 3, b is 2. So that says that c is negative 4. So I think we get f of x is equal to 3x squared plus 2x minus 4. Now I just want to check these by plugging these numbers in. F of 1 is 3 times 1 squared plus 2 times 1 minus 4. That's 3 plus 2 is 5. Minus 4 is 1. F of 2 is 3 times 2 squared plus 2 times 2 minus 4. That's 12. Plus 4 is 16. Minus 4 is 12. F of negative 3 is 3 times negative 3 squared plus 2 times negative 3 minus 4. That's 9 times 3 is 27. Minus 6 is 21. Minus 4 is 17. Therefore, I know this answer to be correct. And that's the unique quadratic function that contains those 3 points. And this concludes the video for section Appendix C2, Systems of Linear Equations in 3 Variables. Objective 1, find the equation of a quadratic function containing 3 points.